We're not hard, like 80, right? It's sunny. It's sunny today.
Now, look at it, like, now it looks like, it'll be cloudy and then I was like, it can change. That's not fine. I got the reference.
It's another 40 minutes.
Hello?
Yeah, you've been needing to lock in. We need to lock in.
Yeah, that's great.
Inform. You got it?
What's that one?
I know that. You're gonna do rules.
Yeah, all second semester is all interviews.
Okay,
Into that.
The watchers are nice. I'm like,
Yeah.
it's like up to page 20, it's all of them. It's like this. Yeah, check it. Oh, that's like exercise, like this family.
okay.
This.
It's awesome.
You can guarantee that. So
Yes.
that we. That's always show me.
We did, but I'm like, a function instead, so I can get out on the calculators. Of the excess. Okay.
Could be so.
This, I'd like for us to work through, if we have time, to work through 2 or 3 FRQs, but probably just gonna be 2. So we're gonna go to the 2022 FRQs. I think I have the 2023 as letters, and then I started page 1 in 2020 for number 1, 2022. So we can flip to that page. We'll work through that one and number 3 if possible. So this is a calculator question, calculator active. Let me read the problem and then we can try it. So from 5 to 10 a.m., the rate at which vehicles arrive at a certain toll plaza given by AFP, where T is the number of hours after 5 a.m. and AFP is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Part A, write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 to 10 a.m. So this was pretty straightforward. You just set up a definite integral. Don't even have to solve it, just have to set it up. Since it says write but do not evaluate. Part B, find the average value of the rate. So average value. So we're thinking average value theorem. So we can apply that for part B. Yeah, that'd be fine.
I don't think so.
This is the key. You can just grab it, just put it back. So practice entering into your calculator. Once we have our average value theorem, we replace A with 1, replace D with
3. Would it be
1. Sorry, 5 and 1.
For the integral in question 8, since it clarifies on question B that 6 a.m. is T equals 1, with 5 a.m. be T equals 0.
5 a.m. will be T equals 0. But we're going from 6 a.m. to 10 a.m. So they're just saying from 1 to 10.
For A.
Oh, from part A. Well, they say from
Oh,
1.
they say 6.
They didn't say 6 a.m. Yeah. We go from 1 to 5.
Have
Yeah.
my calculator. Thank you. Can I borrow for the day?
I'm sorry.
Can I borrow one for the day with this charge?
Oh, yeah.
Thank you so much. Appreciate it.
Okay, any questions with part A or B? Part C is the rate at which the vehicles arrive increasing or decreasing. So you see the combinations of these words, right? Rate is increasing or decreasing. So we know it's going to be something at that second derivative level. Well, we know that A of t is already a rate. We know A of t is vehicles per hour. So A prime would have to be vehicles per hour, vehicles per hour squared. So we basically want to work at the A prime level. So we can make our calculator do that process, math 8 and deriv, make the calculator evaluate the derivative of A at 1. And we're just looking to see if we get a positive or negative number. If we get a positive value, we know our rate is increasing. If we get a negative value, we know our rate is decreasing.
You just look at like if it's positive or negative, and like do you have to compare the like acceleration?
Yeah. So I think the only time you have to compare velocity and acceleration is if it's like an explicit particle motion problem where they ask you, is the speed increasing or is the speed decreasing? That's the only time you're gonna have to compare your velocity and acceleration. Okay, so I think A through C are pretty straightforward. You're just kind of one step to the answer. Part D is the problem that requires a bit more process to work through. But any questions? A through C. Okay, so let's walk through part D. Part D, a line forms whenever A of t is greater than equal to 400. The number of vehicles in line from this unknown A value, they don't give us that A yet, between A and 4 is given by n of t, where A is the time in which the line first begins to form. To the nearest whole number, find the greatest number of vehicles in line at the toll plaza from A to 4, justify your answer. So we see the word, we see these words, greatest number of vehicles. So anytime we see greatest or least, that should be hints that, oh, they're trying to get us to use extreme value theorem. So as a reminder, extreme value theorem means we're going to find our candidates to find our max or min. So we're going to have to find critical points from our derivative, and then we're going to also test our endpoints into the original function. So we know we have to involve setting the derivative equal to 0 to find our critical point. So they give us n of t, right? So if I want to find critical points, I'm going to have to find n prime. So let's find n prime. So n prime is basically find the derivative of this mess. So I need to find the derivative of this. And how can I resolve this? What is this going to turn into? Yeah, we know derivative, integral cancels out. That's nice. We can use second theorem. So n prime is going to be a lot cleaner for us to work with. Basically, just wipe out the d over dx and integral and replace the x with t. So it's a of t minus 400, right? We're not doing power rule for this. We're just wiping this out. And this level, this is sitting at a level above this function. And now we're at this function. And now we can set this equal to 0. And then we can focus on finding our critical point. So we're going to use our calculator. Set n prime equal to 0. So the strategy here is we're going to graph this. and look for the x-intercept. So we may need to kind of practice putting this in our calculator. We may have to play around with our window to get our graph to make it easy to read. So when I do Zoom 6, I'm getting like, they look like almost vertical lines, which makes that a little bit harder for us to trace. So you know that you're dealing with these numbers in the hundreds. So you can just adjust your window, your Ymin, Ymax, just make it maybe like negative. I'm just picking numbers in the hundreds. I just went from negative 200 to 200. I don't know if it's going to actually work. I just want to I know I got to be in that range in order to get my graph to show up a little bit nicer. And that's great. This is what I want, right? I want something that is between something and 4. So I'm going to be looking for these critical points. So from here, you can do second trace, 0. Then take time to find each of these x-intercepts. And they will end up being 1.469 and 3.598. And this 1.469 is also is our A value as well, because this is when the line begins to form. That's our x-intercept. So they didn't give it to us, but we found it as one of our, the critical point we found is also the endpoint for our interval. So we know that we're starting at 1.469. So we now know our A value is 1.469. So we're going to test 1.469. We'll test 3.598, and we'll test 4 because that's the other endpoint of our interval. And they all get inserted back into your N of t equation. And then we're just plugging all this, doing math 9 on this to compare our values. At 1.469, my bounds are not going to change. So my number 0. At 3.598, I'm able to get a value of 71. And then from 1.469 to 4, I'm able to get 62. And comparing these numbers, the most number of cars is going to be 71. Okay, let's see if we can make some progress with number 3. The 2022 FRQs number 3. So flip 2 pages over and get try that one. Now, this one is non-calculator, so we do want to practice a little bit with that. This is a derivative graph here, number 3. Remember, if they don't give you an integral formula like this, right? They're not giving you a they're not giving you something like that, right? They're not giving you a formula. So if they don't give you a formula, but they give you a starting point, then we're going to use this particle motion displacement formula. Final position equals initial plus displacement. And we're going to have to understand that our shader region will give us the area of the shader region will give us information about how far this object is moving, left or right. If I want to find f of 0, I need to start at f of 4. The reason that we start at f of 4 is because that's the anchor point they give us. So we kind of have to start wherever they give us the starting point. And notice we have to go backwards initially. We have to go from 4 to 0 because I'm starting here, I'm ending here. So I do need to set it up as 4 to 0. But because we prefer to read the graph from left to right, after I write this down, I'm going to force it 0 to 4. But with that change, I'm also adjusting with the minus. And then we go to our graph and we see all these shapes that we can fill in with area. From 0 to 4, we see a semicircle, so 1/2 pi r squared. I see a triangle here, positive 1/2, rectangle of 2, triangle of 1. But this is the only region below the x-axis, so I know my displacement is going to be negative there, so negative 2 pi. However, from 0 to 4, this is negative 2 pi, but I got another negative in front, so it ends up giving me a positive 2 pi. So I get f of 4 is 3 plus 2 pi. So therefore, f of 0 is 3 plus 2 pi. F of 5 is a bit more straightforward because f of 5 is just f of 4 plus integral from 4 to 5. There's no need to swap the bounds because we're already naturally moving from left to right. So we should look at our graph here from 4 to 5. It's just this triangle, which is 1/2. So 3 plus 1/2 is 3.5. Part B, point of inflection. Notice that on an F prime graph, a point of inflection is going to be your peaks and valleys, right? Or sorry, your relative max, relative mins. And I do have a relative minimum at 2 and a relative max at 6. So therefore, because this is a derivative graph here, I know my point of inflection is going to be at those points. And the reason why is because F prime is changing between increasing and decreasing. Part C, let g of x equal f of x minus x. On what interval is g decreasing? So we're going to create a slope sine line of g of x. So to create a slope sine line, we're going to just set g prime equal to 0. So g prime is just f prime minus 1. Set my g prime equal to 0. And my critical point is really where f prime is equal to 1. This is how I'm going to get my critical points. There's a little bit of a wrinkle here. Typically, we just look for x-intercept on our derivative graph, but that's not how this is defined, right? Our g prime is not defined as f of x. Our g prime is defined as f prime minus 1. So wherever f prime is 1 is where we're going to place our critical points. Where we're going to place as critical points on our sine line. So f prime is equal to 1 at 5 and 7. You can tell this is the f prime graph. F prime is equal to 1 at these points. So that's why those points go on my slope sine line along with 0, because that's my other endpoint. And if I plug 2 into my derivative, I'll get a negative value. So therefore, I know that this for G prime is a negative. And then if I plug 6 in, F prime of 6 is greater than 1, so therefore positive. So therefore, my G prime is going to be decreasing on the interval from 0 to 5. Or sorry, G of X is decreasing from 0 to 5 since G prime is less than 0. And part D is another extreme value theorem where we got to test endpoints back into your final equals initial plus displacement and comparing all those values to get your maximum. In this case, I'm there.
Why did you subtract 5 on the bottom?
Right here.
Yeah. PDF of 7 minus 7.
Oh, you're right. It should be minus 7. This one by minus 7. So that's going to be. This is also negative 1.5 then. Okay. It's not going to change the answer. My minimum is still going to be negative 1.5. But yeah, that's my mistake. Okay, a few minutes remaining. I encourage you guys to do a couple of problems from 2022 FRQs, even if you can't finish it all. If you can just do 2 to 3 a night, then you're kind of making progress towards completing your FRQs and also getting a lot of reps with the more problems you see, the more comfortable you're going to get as we get closer towards getting ready for our AP exam. The final thing I want to just share with you is that we haven't used AP Classroom for this class, but there's a bunch of resources there. And I think the most useful resource right now is the fact that they have a lot of more recent multiple choice tests. I think we have tons of practice with FRQ, so I'm not worried about that. In your packet 6, there are a couple of multiple choice tests, but these are more recent. So I assigned them just for additional practice. And I also release the solutions as well. So you can, every problem that you do, you also get feedback in terms of what the answer and the solutions are. So if you want additional practice, you should be able to find that in AP Classroom under AP Calculus. All right, come get your phones, return the keys if you have them, and tomorrow we'll work on 2021 FRQs. Hey.
Doing all the problems with both packets, right?
Right? All the problems in both packets. Yeah.